Alright, hi everyone. So this is the second lesson and also last lesson for topic 6 numerical solution of equation. So compared to our previous chapter like differentiation or integration, this is actually a very short chapter which only consisted of like 2 lessons. Okay, so do you still remember what we have learned in the first lesson? Yeah. So we learned about how do we actually find a good starting point, right? So meaning that we want to find out where is the approximate location for our root. So there are two approach that we use. So for the first one is what we call as graphical approach. Okay, so meaning you try to draw graphs and then either you find out the intersection point between the two graphs that you are drawing or the intersection point with the x-axis and you find out where is the approximate location. Okay, so the second one is what we call as change of sign approach. So meaning you are given an interval. So when you substitute your upper limit and lower limit for your interval inside your function, you should get a different sign, meaning like one positive and one negative. So you show that there is a presence of root in between the interval. Okay, so if you have not watched for the first video or if you are not so familiar with the with this idea, I recommend you to rewatch the video and try to make sure that you finish up what you need to do. Okay, because you will find it a little bit confusing if you don't know what happened in the first lesson. Okay, so for the first lesson, it gives us a rough idea where is the root should be. So meaning like a approximate location. So for this lesson, we are going to talk about how do we actually use a iterative formula to help us to determine the root. Okay, so meaning that good starting point give you an idea where the root should be. Iterative formula help you to find out the root. Alright, so for the other one, you can try to read through yourself. So I'm not going to read everything over here, but the idea is that we need to know how do we use iterative formula to find out the root, and you might need to understand some of the concept like why. So which I will try to go through with you everything later. Okay, alright, so let's look at the introduction. Alright, so improving the solution, the iterative formula. So as what I mentioned just now, so the graphical approach and the change of sign approach help us to find out the approximate location for the solution. So in this lesson, we are going to improve it. So one of the common way for us to do that is by using an iterative formula. So which is actually a repeated process that can help us to find a value that is closer and closer to alpha, which is a root that we are finding. All right. So I'm going to split this session into two parts, which is the first part is I'm going to explain to you how do you actually do that. So you might have some of the doubts or questions that you want to ask when you try to go through for the first part, but don't worry, you can just try to follow first, and after you understand how do you do that, and for the second part I'm going to explain to you why we are doing so. Okay, so let's start to do that. Okay, so let's start with the part for how. So I'm going to illustrate the whole process by using the example here. So of course you can see that this is a cubic function where you can actually just use your calculator and you can get the root of it. Okay, but then in a real situation, actually the equation that we might encounter will be something like trigonometry or even like a polynomial up to the degree of 5 or 6, or even you have natural logarithm and exponential. So this is just a simple example which I put in here, which I think it explains the different condition very well. So that's why, and I think it's easier for us to first start it off. Yeah, so that's why I choose for this example. All right. Okay, so let's look at the notes here. So if you have an equation f of x equals to 0, you can rearrange into the form of x equals to fx for some function of f of x. So how do we do that exactly? So this is the equation that you have. So the first thing is let's try to change it into an equation, which what we normally do. So x cubed minus 3x plus 1 equals to 0. Okay, so this is like when we equate our f of x equals to 0, so meaning y equals to 0, right? So when we substitute, this is the equation that we get and we want to find out the root. Okay, so we need to rearrange in the form of x equals to fx, so meaning that in our equation, the x should be the subject. Okay, so maybe let's try to look at this part where you have 3x, so we don't need to have any cube root inside the equation. So I have 3x equal to x cubed plus 1. Okay, then after that I will have x equals to 1 over 3 x cubed plus 1. So you can see now it's arranged in the form of x equals to f of x. Okay, so now we can continue. From there, you can find a iterative equation where x subscript n minus n plus 1 equals to f of x n, which always converge to the root of f of x equals to 0. Okay, so how do we do that? So you can see after you have find this equation, right, we will try to rewrite it again in an iterative formula. So how do we do that? The subject that you have, you will need to have a subscript of n plus 1. Okay, so this is like the rule. You will always do the exactly same thing when you have other equation as well. So for the part for your equation f of x, you will need to change your x in x to the subscript of n. So 3 plus 1. Alright, so this is how you write it. So for example, if let's say now I have x equals to 2x squared plus 3x. So how do I change this? Then it will be x n plus 1 equal to 2x n powers 2 plus 3xn. Okay, so meaning the first subject, just try to do the subscript n plus 1. And for the rest in your function, you will try to put it as xn. Okay, so now let's continue. So how do we do that exactly? So from what we have learned in the first lesson, you know that we should have a good starting point first, right? Which is what we call as the approximate solution. Okay, so in this case, we will try to use a graphical approach to help us to do that. So meaning that we are going to draw the graph for x cubed minus 3x plus 1. Okay, so let's try to see how's the graph look like. Okay, so this is the graph of y equal to x cubed minus 3x plus 1. Alright, so I'm actually use a graphing calculator to help us to do that, so we can try to shorten the time. Okay, so after you have this, then how do we find the root? So we know that the root will be at the intersection point between your x-axis, correct? So these are all your root. Okay, so where is the approximate location? You can see one is near to -2, another one is near to 0.5 and 1.5. Okay, so now let's go back and try to write down these three approximate location. Okay, so let's write down the three numbers, -2, 0.5, and 1.5. Okay, so meaning from the graphical approach that we have taken just now, we know that these three values are a good starting value for us to find out the root. Okay, so how do we improve this solution? So we need to use the iterative formula now. Okay, so let's try to find out the one that is approximate to 0.5 first. Okay, so later I'll show you why do we do this. Okay, so x1, so meaning this is your starting point. We try to fit it as 0.5. Okay, so now how do we improve this formula? So you see, we have this iterative formula, right? So if I have x1 equals to 0.5, can I find x2? So you see, if n plus 1 equals to 2, what is your n? Your n is 1, correct? So 1 over 3 x1 power of 3 plus 1. So what exactly is x1? Is 0.5. So that's why 1 over 3, 0.5 to the power of 3 plus 1. And this gives me the first value, which is 0.375 for x2. Alright, so now can we continue to do this process? Yes, we can continue to x3, right? So what is x3? 1 over 3. So if xn plus 1 is x3, so how about xn now? It will be x2, right? Then cube plus 1. So meaning you are going to substitute the value that you have get just now into your formula again. So cube plus 1. And this will give you the next value, which is 0.3509. So we need to continue to do that. So maybe x4. Okay, so if you have understood how do you actually do this, then you can straight away just substitute 1 over 3, 0.3509 cube, and then plus 1. So same thing, by using your calculator, you should get 0.3477. And we will continue to do this. So x5. Alright, then you substitute your next number. So now you should realize that if I try to use this approach, right, isn't it I need to keep on pressing my calculator for like so many times, and it doesn't make any difference for me if I'm comparing to my trial and error method before. Okay, so why are we doing this? Because your calculator can actually help you to process this in a faster way. Okay, so how do we do that exactly? So by using your calculator, so this is your starting value, and you should realize that what do we trying to do is for your first starting value, you are going to substitute into the formula for you to get the second value. After you get your second value, you will substitute your second value inside a formula again, then for you to get your third value. And you substitute your third value again for you to get the next one, and so on. Okay, so now what we try to do is we will set our answer in our calculator first. So 0.5, so which is my starting point. Then you press 0. So now in your calculator, your answer means 0.5. So the next thing we try to do is we try to put in the formula that we have here. Okay, so 1 over 3, and then what is the number that you substitute every time is the answer that you get previously, right? So that's why answer, then after that cube, so plus 1. Is that okay? So meaning that you are just substituting answer for you to get your next value. So when you press enter, you should get your x2. So 0.375. When you continue to press it, you get the next one, 0.3509. And you enter again, meaning that you are going to substitute this answer back to your equation, right? So that's why you get your x4, which is 0.3477. So when you press enter again, this is how you get to the next one. Okay, so for the next one, you do not need to repeat to write your substitution already. You can straight away just write down your answer. So it's the same thing like in your exam, you can just write down for the first two, then after that, you can straight away just write down your value that you get from your calculator. Okay, so for the x6 and x7, you should realize that you are all getting the same value. So you might have a questions that where do I stop? Okay, so the idea is normally I'll encourage you to get at least maybe 3 or 4 solution that after you round off to the DP that you want, then you can stop. Okay, for example, in this question, let me try to set this question to like find the root to 2DP. Okay, find the root correct to 2DP. So our target here is to make it into 2 decimal places. So meaning when you try to do the iteration, so you should see whether you have, so for example, when you look at your x4, x5, x6, 7, or even start from x3, you should realize that all this number, when you try to round it off into 2 decimal place, it will actually give you the same answer. What is the answer? Which is 0.35. So that's why I know that my first root will be 0.35 when I try to round it into 2 decimal places. So you can just check it by using your calculator also. If you keep on pressing equal to, right, all the number that you can see when you try to round it off, you will always get 0.35. It doesn't change anymore. So meaning all the number converge you to 0.35 when you try to write it into 2 decimal places. Then you can stop already. Okay, so now we have found the first root, which is 0.35. So now let us continue to do for the second one. So let us try to substitute x1 equals to 1.5. Okay, so by using the same method again in your calculator, so just try to set your answer now to be 1.5. So answer, so 1.5 equal to, so after you set, then the same thing, 1 over 3, then you put in answer cube plus 1. Okay, so when you press enter, you should be able to get your first value, which is 1.4583. So I'm not going to repeat the substitution anymore because yeah, I just want to show you the rough idea of it. So 1.3672. All right, and if you try to continue in your calculator, what do you realize? Can you get to a root that gives you the same value when you try to round it into 2 dp? So let's try to just press it in your calculator. So as I continue, I will realize that I reached the step that almost the same like what I have previously, which when I try to round it off, I get 0.35 as well. Okay, so what do you realize? So you remember just now in the graph, right? You should have one root that is very near to 1.5. So obviously this is not the root that we want to find. So we can see that the iteration seems to be failed. Okay, but why? So later we are trying to look at that. Okay, so now you can just put it off. So now let's try to check with the other one, which is -2 here. So when I try to put x1 as -2, what do you realize? So let's try to check it in your calculator again. So answer is -2. So -2 equal to, then I press the same thing, 1/3, then answer cube, all right, plus 1. So when I press enter, what do you realize? The number is actually getting bigger and bigger, and after that it becomes like max error because the answer become bigger and bigger and up to infinity already. So what do you realize? All the value is diverge. So meaning that it's not like the first two that we get, like the number we're getting approaching to a certain value, but for this one it's a diverge value. Okay, so you see now the problems come. There are three roots that we need to identify. But by using this iterative formula, right, it seems to be failed that I only get to one. So how do I actually find the other two, which I have actually confirmed that I have the other two roots? Because this is a cubic, and from the graph that we have just now, obviously I should have three roots. So how do I do that exactly? Okay, so let's try to go back to the iterative formula that we have. Okay, so you see, this is the original equation that I have, right? Do you think that there is only one type of equation that I can form with the subject x in front? So you can see that except this step, right? Except the x here, you have the other x here. Can you try to form the other formula? Yes, let's say I will have x cubed equal to 1, equal to 3x minus 1, correct? So when I try to solve it, then I will have x equals to cube root 3x minus 1. So as what you can see now, right, I have the other equation, which actually means the same thing. They come from the same equation also, but when I try to write it in the form of x, it gives me a different equation. So now can I form a new iterative formula here? Yes, I can. So x n plus 1 equal to cube root 3xn minus 1. Okay, so now we have a new iterative formula here. I want you to try and see now, substitute your x1 to 1.5 and see whether you can get another root or not. Okay, so let's try to do that. So xn plus 1 equal to the cube root for 3xn minus 1. So now let's start with the one that we have filled just now. So the 1.5, because the ideal location that we want to, the ideal solution that we want to get is definitely not here, depends based on the graph that we have. It should be a number that is very near to 1.5. Okay, so now same, using our calculator, we substitute our x1 as 1.5 and see what happened. Okay, so calculator. So the same thing. So you can try to put in your answer, 1.5 equal to, so you want cube root, right? So cube root, then 3, answer minus 1. So as you press equal to, what do you realize? Do you get an answer that is converged to the same number when you try to round it into 2 dp? Yes. You see all this value after you round it, you get 1.53. So this is actually the second root that we are finding. So as you continue to do the iteration, you get the root equals to 1.53 in 2 dp. Okay, so now we have successfully to get the second root here. Now let's continue to the next one, which we actually fill also just now, which is x1 equal to -2. Okay, so same thing, I'll try to key in my calculator. So x2 -2 equal to, and then after that cube root 3 answer -1. Okay, so as I press equal to, then do I get a number that's converging? Yes, it's not like the diverged number just now. So as you see, as you press, you can realize that all this number diverge you to the same number, which is -1.88. So your next alpha should be -1.88. Okay? Okay, so now we have our three roots here. So the first one is alpha equals to 0.35, alpha equals to 1.53, alpha equals to -1.88. Let's try to check with our calculator and see whether it's correct or not. So you know your calculator, you can solve a cubic function, right? So equation, so go to for your cubic. So now you key in, where is your original equation? So it's x cubed minus 3x plus 1. So 1 for the power 3, then after that 0 for power 2, and then -3 for power 1, and constant is 1. So you see, I get this 3 root, -1.88, so it's correct, 1.53, which is correct as well, and also the next one is 0.35. So you can try to compare it with the graph that we have just now. So you will see that it's actually correct as well. So you can see this point is like the one for -1.88. Yeah, so it's relevant, right? It's very near to -2 and like slightly greater than -2. Then after that, for this part is the 0.35 that we have find, so which is correct as well. And this point is 1.53. So as you can see, so this point is like slightly higher than 1.5, so which is correct as well. Okay, so that is basically how iterative formula works. Okay, so now I will proceed to the part where I try to explain to you like why is that so. Okay, so on the part on why. So you might be curious also like why is that for the first formula the first root is successfully obtained but for the other one is failed, and why for the other one it becomes success in this case. Alright. Okay, so the idea is that when you try to look at your learning outcome, right, you are not really required to know the knowledge about the convergence, but you should have a basic understanding that the iteration might fail to converge. Yeah, so that's why try to understand how the whole concept works might be very helpful for you. Okay, so let's try to see this. So what we are trying to prove here is that we want to actually solve the equation for x cubed minus 3x plus 1 equals to 0. So we want to find out the root, right? So actually what we are trying to do is we will try to draw a graph for y equals to x cubed minus 3x plus 1. And you have the other one where it's y equals to 0. And this is basically your x-axis. So when we try to put these two lines together and you have an intersection point, and this is how you find the root. So it's the same thing. Now I have rearranged this equation into a new one, which is x equals to 1 over 3 x cubed plus 1, right? So this is the first formula that we have just now. So meaning that if I'm going to locate them in a graph, so I will have one graph which is y equals to x, and the other graph is y equals to 1 over 3 x cubed plus 1. And we know that when we try to find the intersection point, and this is how we solve the simultaneous, and it gives us to the same equation as well. Okay, so now let's try to compare them into a graph. Okay, so this is the graph that we have just now. So the intersection point is our root, right? So the same thing, I have tried to put in the graph here. So from the equation just now, we know that we have one which is y equals to x, right? Which this one is the line for y equals to 1 over 3 x cubed plus 1. Okay, so now what we try to do is when you try to look at this graph, right, you should realize that because when you try to solve simultaneous, you will get the exactly same x coordinate because when we try to solve these two, it's all give us the answer for x cubed minus 3x plus 1. Okay, so let us try to drop a line between these two graphs. Okay, so you can see the intersection point with this line and the x-axis should be the same x coordinate as the intersection point between these two lines. Because this is how you solve simultaneous, right? And they should give you the same answer. Then the same thing you check for the second root. When you drop down for the intersection point here, it should be the intersection point for the two lines here as well. So the last thing for this point, you will realize that it intersects it as well. So you can see that all these graphs actually give you the same intersection point, which means it can help you to actually solve the equation. Okay, so now let us try to illustrate the whole iteration process by using this graph. Okay, so we have a straight line which is y equals to x and a curve y equals to 1 over 3x cubed plus 1. So let's try to look at the successful iteration first, which is a 0.5. So as you can imagine, if let's say I try to focus on this point and I try to magnify it, what do I get? Then I get something that looks like this, correct? So you can see the green line and then the blue line. So basically, this is what I will get. Okay, so what is the iteration means actually? So you see, this is what we try to do in the whole process, right? So let's try to put it in picture. So the first thing that you try to do is you substitute x equals to 0.5 into this part, isn't it, for you to get x2. So you see, when you substitute x equals to 0.5, let's say 0.5 is here. Okay, so you can see when I try to put in, if let's say this is the point for 0.5, right? What you try to do is you substitute 0.5 into this equation. It's basically the same thing like this. And when you get 0.375, it's like the y that you get, correct? When you substitute 0.5 into the equation on your right hand side, then you get 0.375, meaning that for this part, your y is actually 0.375. Okay, which is exactly the same when you sub 0.5 here. Okay, now next thing, what you try to do, when you try to find x3, you substitute what you have get from your second one, right, which is 0.375 again. So where is the x for 0.375? So go back to our graph. This is the graph for y equals to x, right? So if this point, the x is 0.375, meaning what is the x? The x is actually the 0.375 that we are finding, isn't it? Because x equals to y at this point. So the same thing, after that, what do? I substitute 0.375 and I get 0.3509. So meaning that the next value that I'm getting is actually here. So meaning this point is 0.3509. Because I substitute inside the equation, then this is what I get for my y. So you see, now my old y will put into the new x for this equation as well. So that's why this is my new x again, which gives me exactly 0.3509 as my new x. Okay, then after that, what do? I substitute my new number that I have gotten inside a new equation again to get my next value. So which means when I substitute 0.3509, I'll be getting the next number, which is 0.3477. Then I do the same thing again. I will also put this value to get my x5, right? So when I continue to put this in, meaning that I'm putting my x inside here as well. So 0.3477. So the same thing, then you can see I will keep on repeating and you try to magnify the whole thing. The gap here will become smaller and smaller. So you can see the whole process here, all the value that you have get, right, is actually converging you to the root that you want to find. So that's why when you continue on with the iteration, you can see that all the number that you are finding is actually converged to the root, which is 0.35. And this is how actually iteration works. Okay, so I hope that you can understand. Then after that, we are going to look at the two example, which is the fail one. How is that look like? Okay, so now let's see for the next one, which is a fail one, which just now we want to find the one that near to 1.5. So when we try to magnify the part, where do we get for 1.5? So for the 1.5 is roughly here, right? So the first value that we substitute just now is like x1 equals to 1.5. Okay, so you can imagine what happened next. So you substitute here, then this is how you get to your y, right? Okay, so which is your next value. So after that, you are going to substitute to be your next x. So this is the place for your x1, and you continue. This is how you get to your x2, which this part also give you the x2 lah, which is the one that you get from your x1. So the same thing you are going to substitute over here for you to get your new y. Then after that, continue for your to get your x3. So the same thing happen. What do you realize? You can realize that when you continue on this process, right, the x that you are getting is actually converging to the one root that we have found just now, which is the one that we do for 0.35. So this is why when we try to approach with the second approach just now, it gives us the exactly same root, which is 0.35, rather than this one that we want to find over here. So this is why the method failed. Okay, so now let's look at the one that why is that diverging. Okay, so now we are going to magnify for this part for -2. How is that look like? Okay, so this is the magnified graph and I'm going to show it here. So as you can see, the blue line is the curve and the green line is the straight line. So our iteration is xn plus 1 equals to 1 over 3xn plus 1, right? So meaning when I substitute my first value, which is my -2 here, then the y that I am getting, meaning the new x2 that I'm getting is over here, correct? Okay, so you see, don't sub in the wrong equation because you are putting in inside here. So meaning that if the with the blue line, not the green line, so that's why the y is here. Okay, then after that, you are going after you get your new value, you are going to substitute this as your new x2, right? We should try to extend it here, and this is how you get your second x over here. So which is your x2. So the same thing, you are going to substitute your x2 and to get your x3. So the same thing, I'll expand it here. And this is how I get my next value over here. So I'll try to expand it again. Then this is how I get my next value, which gives me my next x3. Okay, so you can imagine if I want to continue with this, meaning that I might need to extend my curve over here. Okay, then after that it dropped down to this and then it gave me a new y again, then I continue to do that. So from what you can see here, right, instead of like the type of graph that we have just now, which converge everything in one root, so every value that you are getting is giving you a value that is further and further from the root. This is actually consistent with the idea of when you try to press in your calculator, you get the number become bigger and bigger. This is why just now we said that it's diverged. You remember? So I have set in here, yeah. So the first value that I get for my x2 is -2.3. So you can see -2.3 is roughly here. So when I substitute again, I get my next value over there. So you can see it's roughly -3.9. Yeah, so I mean, it's not accurate lah. I mean, because of the drawing and so on. But the idea is that you can see it's like -3 point something over here. Okay, so as you proceed, you can see that you can imagine that if you try to do this again and again in this graph, it will actually brings you further and further from the graph, which from your calculator, you get a number that's bigger and bigger. So this is why this iteration failed. Okay, so I hope that you can see like the three conditions that happen in this case, which why is that a successful for the convergent case, and why is that is converge but give you the same root, and also the last case, which is the divergent one. Okay, so now you remember just now we have built the other equation, right? Okay, so this is the equation that actually allows us to find the other two roots, right? So if you have your graphing calculator like online one, you can just search like Desmos also. So the idea is you can just draw a line y equals to x and also y equals to cube root 3x minus 1. okay, which is stated in the iterative formula that you have. Then you try to do the same thing like what we have done just now and see whether you have a convergent series which allows you to get these two answer. Okay, so I'm just going to show it in like a very quick way. So because I do not want to spend too much time, yeah, I guess the explanation is pretty long here. So later we are going to look at some of the example of the questions. Okay, so now we'll be looking at four examples together, and you'll realize that actually the questions have like kind of the same pattern. So just to let you know that normally iterative formula is like for us to find out the solution for certain equation. So that's why normally this kind of questions is like in most of the cases it will be related to other topics. So meaning that it can be an exponential equation that you can't solve and you will try to use iterative formula to solve it, or even like in trigonometry or circular measure. So that's why you can see like for the example that we are going to look at later, so you can see that you will need some basic knowledge for the previous topic for you to answer that. Okay, so let's try to look at example one first. Okay, example one. So the equation given here has a negative root alpha. Show that this equation can be rearranged in x equals to 3 over x minus 1. So I guess this is easy. So you just rearrange the equation that you have. So x squared plus x minus 3 equals to 0. So meaning that I can always write x squared equals to 3 minus x, and when you divide by x then you get x equals to 3 over x minus 1. Okay, so proved. Alright, so after you have get this, let's proceed to B. So use the iterative formula xn plus 1 equals to 3 over xn minus 1, okay, with the starting value. So you can see that normally in all the questions that involve iterative formula in your examination, right, they will try to give you the formula, which means that for the just now example is the example that I want to show you like how's everything actually work. But in the exam itself, I mean, they try to avoid the situation where you need to try out so many different conditions. So that's why normally they will try to give you the iterative formula so that everyone can get to the same answer. Okay, so the same thing, we need to start with the starting value of negative 2.5. Alright, so I hope that you still remember how do you use your calculator to do that. So if you are worried about whether you need to write the substitution or not, then I'll recommend you for the first two, maybe you can just try to write it. Okay, so negative 2.5 minus 1. So they ask you to give the result of each iteration to 4 decimal places. So that's why negative 2.2000. Okay, so for the next one, then if you want to write, then you can rewrite it again. So 2.2 minus 1, and you will get negative 2.3636. Okay, and after that, you do not need to repeat this substitution again lah. You can straight away just use your calculator to get your answer. Okay, I'm just going to repeat one last time over here. So what you need to do is you just keep your key in your answer. So negative 2.5 equal to, okay, then after that 3 over your answer and then minus 1. Okay, so when you press, you should get your first value 2.2, and then after that your next one 2.3636, and you get your x4, x5, and so on. Then you just try to copy down in your worksheet. Okay, so I'm just going to write it here. So equal to negative 2.2692 x5 negative 2.3220. Okay, then you have x6, which is negative 2.2920. Can proceed. Okay, so as what I say, you need to look at the questions itself. So you see the question 1 to find the root correct to 2 decimal place. So that's why you should check to have at least so normally sometimes they will say 2 is enough, but if you want to make sure that your answer is correct, then you can leave it up to like 3 to 4, where after you round it, then you round it to the decimal places that you want, and you get the same value, then you can stop. So for example, you can try to see that for this one, when I round off, I get negative 2.30. For this one, I get negative 2.31. So you know that you cannot stop here yet. So you need to proceed. So negative 2.2993. So this one, I get 30. So you see it's not same again. So I need to continue. Negative 2.3047. Yeah, you are almost there, because you see 3047, when you try to round it, then you get 2.30, which is the same with x8, right? So you can continue with 1 or 2 more, so depends on you. Yeah, that's totally fine. Okay, so maybe you can do up to x11, and you can see that from x8 to x11, actually after you round it off, every value here will give you that it's converged to negative 2.30. So that's why you can write it down. Alpha equals to negative 2.30. And then this is the answer that correct to 2 decimal places. Okay, so normally this requirement will be given in your questions lah. So after you do this, you cannot stop here yet, because you see actually this number is still in the process of converging, but we can't afford to just write everything up to the point where it doesn't change anymore. So that's why we need to prove that any number within the range of number that you are going to get will round off and give you this. Okay, so if alpha equals to negative 2.0, then we will try to form a range. So what is the range of the number that after you round it off to 2 decimal places will give you this one? It will be from negative 2.305 up to negative 2.295. Okay, let me try to explain this further. Why do we choose this? Okay, so the idea is that you see, when I have a number that is, so what is the example of number that fall under this range? It will be like 2.304, negative 2.302, or negative 2.299, negative 2.297. Yeah, so these are all the example that falls under this interval, right? So as you look at this 4 number, right, every time when you round it off, isn't it, they give you this number? So that's why when you try to check that there is a presence of a root in between this interval, and you know that no matter what is the value that you get for the root, after you round it off, you get this one. So if let's say you say, if can I do other range? Okay, let's try it out. So if let's say you are not doing 0.005 as the lower and the upper, then maybe you say, can I try to do negative 2.35 to negative 2.25. Okay, so maybe that's your doubt. Okay, now let's see what is the value that falls under this interval. You have negative 2.33 maybe, then you have maybe, let's do the other one, maybe you have negative 2.28. You see, for these two example, when you try to round it off to 2 dp, do you sure that it gives you this? No. If I want to do it in 2 dp, then this is exactly my answer already, right? 2.33 in two decimal place, 2.28 in two decimal place. So that's why even you prove that there is a presence of root in between this one, it doesn't mean that all the value that I get after I round it off, it gives me this answer. So that's why every time if you need to correct it into two decimal places, then normally for your range that you need to check, then it will be 0.005 for the lower and the upper. So if you are checking for 3 dp, then meaning that you are going to do 0.0005 lah. So lower minus, then the upper one is plus. Okay, so that's the idea of it. Okay, so now how do we verify this? So you have learned about the change of sign, right? So now we need to substitute. So how do we do the substitution? Okay, so we need to check on the equation that given in the questions. So we have x squared plus x minus 3 equals to 0, right? So let's start with that. So x squared plus x minus 3 equals to 0. Okay, so when you have an equation that on your right hand side equals to 0, then you can try to change it into a function. So let fx equal to x squared plus x minus 3. Okay, so now we can try to substitute this value that we want. So start from negative 2.305. Okay, so as you substitute, then you will be able to get the value of positive 0.008025. Okay, so let's check for the next one. So when you substitute negative 2.295, right? So the substitution. So I'm just writing down everything for the first question so you understand actually what is going on here. All right, so minus 3. So when you try to key in your calculator, you'll be able to get negative 0.02798. So from here, you have one positive and one negative. So you know that there is a presence of root between this interval, right? So since from the explanation just now, I hope that you can understand already any numbers that between this interval will give you the root, which is negative 2.30 when you try to round them into two decimal places. Okay, so that is why. So you write down your last verification. So the change of sign indicates the presence of root. Okay, indicates the presence of root between negative 2.305 and also negative 2.295. Okay, and this is why you conclude that the root will be equals to negative 2.30 when you try to round it into two decimal places. All right, okay, so please be mindful that this part, meaning the last part for the verification, right, is the compulsory part that you must do when you try to carry out iteration. So this is the part that actually, because you see, when we try to do iteration, right, you know that this number is going to be changes again when you continue to find x, 12, 13, and so on. So what is the justification that you can say that your answer is negative is 2.30 is because of or when you try to substitute inside this interval and you get different sign. So that's why you know that there is a presence of root over there, and you can say that the answer is negative 2.0 when you try to round it into two decimal place. Okay, all right, so let's move on to number 2. Okay, number 2, the equation e to the power of x minus 1 equals to 2x has a root alpha equals to 0. Show by calculation that this equation also has a root beta such that beta is between 1 and 2. Okay, so the first thing that you need to do is from here, you need to verify that there is a root, right? Meaning that you need to use the change of sign approach. Okay, so we need to find out what is our function first. So it's given that ex minus 1 equals to 2x. Okay, so you must remember before we can change it to f of x, you must make sure you rearrange this in equation form, meaning that it should be equals to 0 on your right hand side. So that's why this is how we get e to the power of x minus 1 minus 2x equals to 0. Okay, so now we can try to write let f of x equal to e to the power of x minus 1 minus 2x. Okay, so now you have your function of x, so we can substitute the beta and check. So f, let's substitute 1. Okay, so you get e1 minus 1 minus 2 times 1 minus 2 times 1, which will give you your first value, negative 0.2817. So do the same thing for f2. So for f2, you substitute 2 for all the x part, and you will be getting 2.3891. Okay, so as you can see, you have one positive and one negative. So meaning that there is a change of sign, right? So change of sign indicates the presence of root between 1 and 2. All right. Okay, so that's it for the A part. So now let's move on to the B. Okay, so B, show that this equation can be rearranged and in the form of x equals to ln 2x plus 1. Okay, so this is about rearranging it in a form of x equals to f of x. All right, so the same thing, let's try to write down the equation that we have here. So ex minus 1 equal to 2x. Okay, so we have e to the power of x equals to 2x plus 1. So when we want to put our x as the subject, meaning that you will try to ln both sides, right? So ln ex equals to ln 2x plus 1. So when we have ln for 2, so you can see that for ln ex, it actually gives you x. So x equals to ln 2x plus 1. Or it's just the same thing if you know how to change this. So like you left with your x then equals to ln 2x plus 1. You're getting the exactly same thing. All right, so that's it proved. So move on to C. So for C, you need to use the iterative formula. Okay, use an iterative iteration process to with a suitable starting value to find your beta, so meaning that to find the root. Okay, so now we have an approximate location here which is between 1 and 2, right? So with a suitable starting value, so it doesn't matter that which value that you are taking, so it will give you the same answer. Because with the explanation just now, so you understand that no matter where you start, along the process, you will be getting a number that is converging to your root. Okay, so it's okay whether you want to start from 1.5, 1.4, and so on. So depends on your own reasoning. Okay, so now let's try to write down our iteration formula first. So remember your subject, it has to be x subscript n plus 1. And then for your x inside your function, then it will become x subscript n, okay, plus 1. So now we can start to do the iteration process. So in this case, then depends on you. So from what I see here, then normally how do I decide is I will try to look at when I try to check for my change of sign, right? If f of 1 give me negative 0.2817 and f of 2 give me 2.3891, obviously that you can see that for the f1 is actually nearer to 0, which is where my root should be. Okay, so that's why when I try to choose, then I wouldn't choose a number that is nearer to 2 because the number should be further than 0 compared to the 1. So that's why in this case, then I might start with maybe 1.2. Okay, so this is a number that is nearer to 1 and is further from 2 because like you can try to imagine the whole situation like being in a graphical approach. Okay, so but yeah, by like what I said just now, if you start from 1.8 also, you will still get the exact same answer. Okay, So the same thing, you will try to use your calculator. So maybe for the first one, we try to write it down. So you will try to substitute ln to 1.2 plus 1. Okay, and you'll be able to get the first value, which is 1.2238. Okay, so for the rest one, you can just take it from your calculator. So remember the answer, the questions want you to give your result for your process in find significant figure. Okay, so that's why you should give your answer in find significant figure. So let me just write down the answer that I got from the calculator. So if you forgot how to do this with your calculator, please refer to questions 1 or the example that we have gone through just now. Okay, so I guess this is good to stop because as you can see, you have around three numbers here. After you round it off, you get exactly the same answer, which is 1.26. Okay, so as written in this question that you should write your beta in three significant figure. So that's why you can see that for the last few values that we have here, when you try to round it off into three significant figure, you get the same value, which is 1.26, and that's the part where you can end already because by all means we are going to verify it after that. Okay, so that's why or in your calculator you just can try to keep on pressing it lah. So you should realize that no matter how you proceed, you will get the same value, which is 1.26. Okay, so that's why you can just write down your beta will be equals to 1.26 when you try to correct them into three significant figure. Okay, so as what I said just now, this is like a roughly guess from us. So because of all the value will give us this one. So how do we further verify that? So we'll need to check on the change of sign approach again. Okay, so if beta equals to 1.26, then I will need to check that for the range for 1.255 until 1.265. Okay, so the logic behind it I already explained in question 1, so I'm not going to explain it again. But then the idea is you have two decimal places here, so that's why when you want to check, then you just plus and minus 0.005 for your lower and upper. Okay, because all the values within this range will give you 1.26 when you try to round it off. Alright, so now let's try to substitute in the functions that we have. So ex minus 1 minus 2x equals to 0. So ex minus 1 minus 2x equals to 0. Okay, so we can form our fx, or I think actually we did it in questions 1 also, in part A also. Okay, doesn't matter. So f of x equal to e power x minus 1 minus 2x. Okay, so now we can substitute the two value that we want to check over here. So the first one is 1.255. Okay, and after you substitute in this equation, then you should be able to get negative 0.00216. Okay, so we do the same thing for the upper part, which is 265, and you will be able to get 0.0131. Okay, so you can see that there's one negative and one positive, so that's why the change of sign indicates presence of root between 1.255 and also 1.265. Alright, so now you will write down your last answer. So because of the presence of root is between this range, right? So no matter what value that you get, it will give you the same answer, which is the beta will be equals to 1.26 when you try to convert it into three significant figure. Alright, so this is how we answer number 2. Okay, so now let's move on to number 3. Okay, let's continue to number 3. Let's start from the A part first. Okay, so 3A, this is a proving question. So as you can see, trigonometry, so meaning that you should use like some of the formula that you have learned previously to solve this equation. Alright, okay, so let's start with the left hand side, I think. Okay, 1 plus cos x over 2 sine x square plus 1 minus cos x over 2 sine x squared. Okay, so let's continue. Maybe we need to expand in this case. So 1 plus 2 cos x plus cos square x. Okay, divide by, so I think you have the same numerator denominator, so we can straight away combine it here, which after that you will be able to get 4 sine square x. Okay, because you square it. So on this side you have plus 1 minus 2 cos x and then plus cos square x. Okay, so we can continue. Let's solve the part where you can do it. So 1 plus 1, 2, and then 2 cos x minus 2 cos x give you 0, and plus 2 cos square x. Okay, then for the denominator, it's still the same. Alright, so since that they all have the factor of 2, so we can try to factorize them. So I'll be able to get 1 plus cos square x and then divide by 2 sine square x. Okay, so as we reach this step, you can see that for the part where we need to solve, you have two parts, right? So meaning that what do you need to do? So from the fraction itself, you need to split it back to 2. So you have 1, which is 1 over 2 sine square x, and the other one plus cos square x over 2 sine square x. Alright, so now let's simplify. So 1 over, so reciprocal of sine give you cosec. Okay, and then plus, so cos over sine is cotangent, right? So 1 over 2 cotangent square x. Okay, so there is a formula in your trigonometric identities that tell you that cosecant square is equal to cotangent square plus 1. Okay, so this is how we can continue. 1 over 2 cotangent square x. So 1 over 2 cotangent square plus 1 over 2 cotangent give you cotangent, right? So cotangent square plus, so when you expand this, you get 1 over 2. Okay, I think that's the part that you need to prove. Yeah, so cotangent square x plus 1 over 2. Okay, so proved. So now let's move on to the next part, which is B. Okay, so you need to show that hence given that alpha is a root for this equation equals to x, show that alpha is also the root for the equation x equals to shift tangent square root 2 over 2x minus 1. Okay, so meaning that what do we need to prove is from this equation to become this equation. So let us start to copy from what we have here first. So 1 plus cos x over 2 sine x squared plus 1 minus cos x over 2 sine x squared equals to x. Okay, so as for A, we already proved that for this part, it's equal to cotangent square x plus 1 over 2, right? So that's why we can try to straight away substitute the part that we have proven into B. So cotangent square x plus 1 over 2. Okay, of course you might take a close look at whether this and this isn't it the exactly same thing lah. Okay, so yeah, after you have changes it, then now equals to x. Okay, so now you see that you need to rearrange the whole function again to be a function of subject x and equal to fx. So that's why let's try to rearrange the equation that we have here. So cotangent square x equals to x minus 1 over 2. So let us try to combine them together. So cotangent square will equals to square root. So for this part, when you combine the fraction together, because you can see it's combined, right? So that's why you will have 2x minus 1 over 2. Okay, so as for cotangent, then we want to get to tangent first before we can put it as tangent negative 1. Okay, so in this case, we have cotangent equals to 1 over tangent x, right? So you can imagine later what happened is you will try to put it upside down. So the square root can be always split it into two parts, like square root 2x minus 1 and then square root 2. Okay, so as you try to rearrange it, then when you try to solve for tangent x, then it will be equals to square root 2 over square root of 2x minus 1. Okay, so now as you have written in this form, then let's try to combine them back together. So tangent x will be equals to square root 2 over 2x minus 1. So when we solve for x, then it will be tangent -1 and then square root 2 over 2x minus 1, which is what is given in the questions here. Okay, so now is the end for the B part, so proved. Okay, so now let's move on to C. Okay, so it is given that alpha is the only root for the equation that you have proved just now. So verify by calculation that the value of alpha lies between 0.9 and 1.0. Okay, so this is the questions that you need to deal with the change of sign approach again. All right, so since you have this equation already, so let's try to rewrite it again. So tangent -1 square root 2 over 2x minus 1. Okay, so same thing, before you can put it into f of x, you must rearrange it in an equation that right hand side equals to 0. So that's why x minus tangent -1 square root 2 over 2x minus 1 equals to 0. Okay, and after that you can let your fx equal to x minus tangent -1 and then 2 over 2x minus 1. Okay, now we can start our substitution. So let's start from 0.9. So f 0.9, when you try to substitute in the function, you will be able to get -0.10685. Okay, so please try to check it with your calculator. So continue with 1.0. So you'll be able to get 0.044683. Okay, so you can see that you have a different sign, so which means it's proved, right? So same thing, you need to write down your verification. So the change of sign indicates the presence of root between 0.9 and 1.0. Okay, so that's the idea, but verify by calculation and find that your root lies between this interval. Okay, so let's move on to D. Use an iterative formula based on the equation in part C. Find the value of alpha to three significant figure. Okay, so since for the part for C, we actually already rearrange it in the form of x equals to f of x, right? So we can straight away use this formula to form our iterative formula. So x equal to tangent -1 2 over 2x minus 1. Okay, so you need to rewrite it in iteration form. So x subscript n plus 1 and then tangent -1 and same thing in your function, you should change your x to be x and okay minus 1. So after you have written your iterative formula, then now we can start the iteration. Okay, so x1. So same thing, I think this question they didn't give you the starting point also, so you need to determine by yourself. So in this question, you can see that just now you have verified that for 0.9 is -0.1, for 1.0 is 0.04. So that's why you can see the number here. You can imagine that your root should be a number that is nearer to 1.0 rather than 0.9, because for 1.0 is the value itself is nearer to 0 compared to the f 0.9. So that's why in this case, I will choose to start from, let's say, 0.97. Okay, but it doesn't matter also if, let's say, you want to try out the other number, you also can do that. So I mean, until the end, you will still get the exactly same answer as what I have gotten here. Okay, please make sure that your calculator is in radian form before you proceed with it. Okay, so normally in iteration or even like the calculus that we have learned previously, no matter differentiation or integration, so normally our angle will be in terms of radian. Okay, so let's try to do it again. So 0.97, set it as answer. So shift tangent and then square root 2 over 2 answer minus 1. Okay, so you can see that you will get your x1, yeah, which is 0.9698. So same thing, I think you can write down your answer in 5 significant in this case because you are required to give your answer in 3 significant figure. So you can imagine that you need, since your first value is 0, right? So meaning that you need 3 decimal places. So it's good that maybe we can try to do 5 decimal places here. Okay, so same thing, I'm just going to write down the value that I will get in the calculator. So please try to record on your own. So yeah, okay, so as you proceed, you should be able to see that actually all this value give you the same answer when you try to round it into 3 significant figure. So as you see this one, when you round off, you get 0.970. Same thing goes for 3, 4, 5. So again, you can try to just check it out with your calculator, like continue to press it, and you'll be able to see actually no matter as you proceed, right, you will still get 0.970. So we can stop here. So you can write down your growth will be equals to 0.970. So this is correct to 3 significant figure. Okay, so please make sure that you write 970, although it's the same with 97, but you need to write your answer in 3 significant figures, so that's why. Okay, so the same thing, the last part before we confirm this answer is we need to do the checking part. So if our alpha is equal to 0.970, which means it gives us an interval that is from 0.9695 to 0.9705. Okay, so the idea is because you have 3 decimal places, right? So that's why it should be 0.0005 minus and 0.0005 plus. Okay, so after you get this range, then now we can continue with the substitution. So please try to rearrange your formula first before you do this step. Okay, so in your formula, you have your x minus tangent negative 1 2 over 2x minus 1. Okay, so equals to 0. So you have f of x equal to x minus tangent negative 1 2 over 2x minus 1. Okay, I think you have gotten this formula also from your part C just now. Okay, so now we can continue with it. So f of 0.9695. So when you substitute, you'll be able to get negative 0.00052720. So when you substitute the other value, and you will get a negative, it's positive 0.000924. Okay, so as you can see, you get a different sign as well here. So that's why the change of sign indicates presence of root between 0.9695 and 0.9705. Okay, so that's why any number between this interval will actually give you the same answer when you round it off into 3 significant figure, which is 0.970. Okay, so let me try to explain it again, like why this range is chosen. Like for example, if let's say maybe you have a doubt that if let's say this is my root, right, can I try to verify for this range, meaning that this range rather than the range that we did just now. So the idea is, you remember just now I said for the range that we built, all the value that available in this interval must be a value that gives me 0.970 when I round it off to the significant figure that I want. So in this case, if you are checking for this interval, right, what is the available numbers in this range? It will be, for example, 0.968 or even 0.972. So when you look at these two value, right, when I try to round it off into three significant figure, what do I get? I get what it is, correct? Because I mean, when I round into three significant figure, this is already in three significant figure. So that's why by having this value, it didn't give me the 0.970 that I want. So which means that even though I try to verify one negative and one positive here, it doesn't give me a verification or a confirmation that this will be my answer because this range is like too big. For example, if let's say I try to check from zero to 1, then of course I know that there is a presence of root, but I can't prove that it's this value. So this is why it's very important for you to find out the right value when you try to verify your root. Okay, so that's the idea. So as what I said, if you are doing for two decimal places, then you put 0.005. So if you are verifying for three, then you are doing 0.0005. Okay, and so on. All right, so let's move on to the very last questions here. Okay, the last one, I hope you have finished trying here. All right, so yeah, because the idea is just the same, but then it's just the questions itself and the equation is based on different topic that you have learned previously. So that's why, yeah, I hope that you can try your own before you look at the answer and so on. Okay, so this question is about the circular measure that you have learned in your Pure Max 1. So yeah, so let's try to do for the A part, show that theta equals to 2 sine theta. Okay, so it's given the information that AB is the arc for the circle with center C. The area for this shaded segment is the same with the area with the shaded triangle. Sorry, the area for the unshaded segment is the same with the area of the shaded triangle. Okay, so let's start to do that with the information that given. So you have the area for the segment. It will be equal to the area of the triangle. All right, so how do you find the area for a segment? So a segment is basically the area for a sector. You minus off the triangle that you have, right? So that's why for the equation for a sector, it will be 1 over 2 r squared theta. Okay, so the theta is given here also in your angle as your angle. So that's why you can proceed with theta. So you need to minus off the triangle that you have here. So for the formula for triangle, we have 1 over 2 AB sine C, right? Which means you have a triangle, which you have two known side and one angle in between the A and B. So in this case, you have theta, and then AC is radius. Your BC is also the radius. So instead of writing AB, then you can straight away 1 over 2 r squared sine theta. Okay, it will be equal to the area for the triangle, which means it's the exactly same thing which what you have got here. So 1 over 2 r squared sine theta. Okay, so let's try to simplify it. So you have 1 over 2 r squared theta minus sine theta equal to 1 over 2 sine r squared sine theta. So you can see you have both side 1 over 2 r squared. So now we can try to uh cancel it out. So you have theta minus sine theta equal to sine theta. So rearrange and simplify it, then this is how you have theta equals to sine theta, sorry, 2 sine theta, which you get here. Okay, so proved. So let's move on to B. Showing all your working, use an iterative formula based on the equation in part A. Given the initial value, then you need to find out the theta. Okay, which means we actually need to solve this. So this is the idea of like why numerical solution is important, because when you look at this equation, you actually can't solve it uh, with the algebra knowledge that you have learned so far. Okay, so that's why we need numerical solution, which means the iterative formula that we are doing now. Okay, so okay, let's rewrite the iterative formula. So theta n plus 1 equal to 2 sine theta n. Okay, so now same thing, just by using your calculator, starting with the initial value that is given, which is 1.85. Okay, then you can use your calculator to proceed with your theta 2, theta 3, and so on until you get a number that is the same when you try to round it off into three significant figure. Okay, so I'm going to write down the value that I obtained. Okay, so up to this point, you should realize that for your last three number, it gives you the exact same number when you try to convert it, when you try to round it into three significant figure, which is give you a convergent series, which your data is equal to 1.90 radian in three significant figure. Okay, so after the 12th value, you can actually try it out in your calculator and just pressing it, and you should be able to see that for every value that you get, it will give you the exact same answer after you have rounded it. Okay, so after that, we need to do the verification like what we always do after we get the root. So we have the equation, which is theta equal to 2 sine theta. So let's try to rearrange it in equation first. So what you get is theta minus 2 sine theta equals to 0, right? So we can rewrite it and form our fx. So let f of x equal to theta minus 2 sine theta. Okay? So now we need to do the verification. So since theta is 1.90, so the interval that we might need to check will be 1.895 up to 1.905. All right, so let's do the substitution. So when you substitute 1.895, you will be able to get your answer as 0.000894. So when you substitute 1.905, you will be able to get negative 0.01565. Okay, so you can see the sign is different. So that's why same thing, we need to write down our justification. So the change of sign indicates presence of root between 1.895 and 1.905. Okay, and hence all the value that available within this interval, when we try to round it into three significant figure, it will always give me theta equals to 1.90 radian. Alright, so with this answer, now we are going to solve for the last part, which is the C. Find the length of AB given AC is 8. So AC is 8, which means that the radius given here is 8. And the questions want you to find out AB. Okay, so since that for B, we already solved what is the theta just now, right? So theta is 1.90. Okay, so depends on you. You can use cos rule also can, since you have both AB, because BC is also 8, right? So you can use cosine rule. Or if you don't want, then the easiest idea is to just do to just use a right angle triangle and use a normal SOHCAHTOA to solve this. So you just split the triangle into two right angle triangle. Okay, so this is the half of AB that you are finding. So since you have this angle here, which means you are looking at opposite and hypotenuse. So meaning we use sine here. Okay, so sine for half of the data, which is 0.95, will be equal to half of AB. Okay, because the opposite that you are finding is just half of AB, right? Over the hypotenuse, which is 8. Okay, so for you to solve it, then 1 over 2AB will be equal to 8 sine 0.95. So you continue to solve for your AB, which is multiply the whole thing with 2, then you'll be able to get 13.014 cm. Okay, so that's it for this question. So it's basically solving a trigo equation. Then after that, use your solution to help you to find other variable that you need. Okay, so that's it for this lesson. So as you continue to for your exercise, you will realize that actually the pattern is just keep on repeating again. So the question are asking for the same thing. It's just that they put in into a different criteria. Okay, so if you have any questions, then you can ask me personally again after this. Okay, so that's it. Thank you.